All right, in this video, we are going to talk about distance and diameter in a graph. So let G be a graph and let x, y be vertices of G. Then the distance from x to y in G, denoted by d of x, y, is the length of the shortest path from x to y. If there is no path from x to y, then the distance between x and y is just defined to be infinity. Okay, so here in this graph we have vertex A and vertex B. They would be distance 1 from each other. And vertex A and vertex E would be distance 2, right? Vertex A and vertex F distance 3. And vertex A and vertex I would be distance 4, all right? So that's a pretty straightforward definition. The diameter of a graph G is the maximum distance between any two vertices of G. So here we can see that that the diameter of this graph is 4, right? Because the maximum distance, right, between any two vertices is the distance from vertex A to vertex I. Okay. That is of length 4. So the shortest path between A and I is 4. Everything else, right, is going to be smaller than that. Okay. So diameter 4 here. All right, some of the graphs that we've talked about before, their diameters, the diameter of the path graphs is just equal to the number of edges in the path. So diameter P0 is 0, diameter P1 is 1, diameter of P2 is 2, and so on and so forth. All right, on the cycle graphs, it is related to half the number of vertices. So over here for the even lengths, it's exactly half, right? So here this is diameter 2, C6, diameter is 3. And for the odd ones, you divide by 2 and then take the floor of that. So 3 divided by 2 is 1.5. The floor of that would be 1. And you can see it's the distance between any, the shortest path between any two vertices is of length 1 here. 5 divided by 2 is 2.5, and take the floor of that, you get 2. 7 divided by 2 is 3.5. Take the floor of that, you get 3. So you can see if I pick this vertex here, then it's going to be 3, either from here going around this way or going the other way. And it's going to be 3 is the point that's farthest away. All right, and then the wheel graphs, the diameter of W3 is 1 because every vertex is got an edge to every other vertex here. But for all the other wheel graphs, it's 2. Okay, so if you want to get from one vertex to any other vertex, you can just go through this center and then go to the other vertex, and that's true of all the wheel graphs. All right, and then finally are the complete graphs. The complete graphs have diameter 1 for every one other than k sub 1 here. And that's because every vertex is connected to every other vertex. All right, and that is it on distance and diameter. You will need to use that in the homework problem. All right, that's it.